Okay. Go ahead and write down the first one while I get situated. The second one. Go ahead and take the first derivative and I'll catch up with you. Alright. So the first derivative of this is something raised to the 2/3. So the first derivative is 2/3 times that something raised to the 2/3 minus 1, which is 3/3, so minus 1/3, times the derivative of that something, chain rule, 2x. Alright, so let's clean that up a little bit. F prime of x equals, I can combine the 2x and the 2 and get 4x, and everything else is downstairs, isn't it? The 3 is downstairs, and I'll write this as a cube root, which is what it is, x squared minus 4. Alright, so that's the first derivative in a simplified way. And let's look at the values that would cause this to be 0 or not exist. So, can you see that if this x is 0, the whole function is 0? Alright, so we're setting this whole thing equal to 0 now, and finding out that for that to be, this whole thing to 0 out, if x equals 0, that definitely will 0 out the whole expression. So therefore, that is one of our points of interest. I don't see anything else that will cause that expression to be 0, but I do see some things that would cause that expression to not exist. In other words, if it would have a 0 denominator. Can you think ahead of me? What value would go in here and cause that denominator to be 0? Because critical values are also where the derivative does not exist. So analytically with algebra, that's where the denominator would 0 out. So do you see that that would happen at x equals 2 and also at minus 2? Alright. Alright, so those are our values that we're going to put on the number line. So x equals, this time I didn't give you an interval, so we'll just come from negative infinity to negative 2 to 0 to 2 to positive infinity. So those are our test intervals, and in those we're looking for where the derivative changes from a negative to positive or positive to negative. So in here, the test value I chose was negative 3. So I'm testing negative 3. When I put that into that function, it came out to be negative. And then in here, I tested negative 1. I'll just circle my test values. When I put a negative 1 in there, that expression there became positive. And then between 0 and 2, I tested 1. And when I did that, I got a negative value. And lastly, between 2 and infinity, I chose 3. And that gave me a positive value. So, without me drawing my humps and valleys, can you tell me what is this right here? Is it a relative max or a relative min? Well, the function is going from a negative to a positive derivative from a negative to a positive, so it must be a relative min right here. Negative to positive. So sort of like this, negative to positive. Alright, now it's going from positive to negative. So we have a max. And here we go from negative to positive. And we're done. So we have, now in your assignment, I'm only giving you the x value of the relative min, the relative max, and the relative min. Probably they want the x and the y, so easily solved. Just put that negative 2 into the original and you'll get the corresponding y value at each of these x values. All right, here's one for you. Try this one in your comp book, and we'll discuss it tomorrow. F of x equals x to the fourth plus 1 divided by x squared. All right, so look at that, and I want you to use the first derivative test, find the critical values, and apply the first derivative test at each of those to see if you have a relative max or relative min. All right. All right, bring that all complete and ready to go tomorrow, and this will reflect your work tomorrow as well. All right, hope you have a good rest of your evening. Good night, sweet dreams. Till the morning, see you then.